From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 289, recorded live Thursday, October 13th, 2011. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Phil Price from the Visual Studio team about performance and PerfWatson.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. Today, we're going to talk about performance, specifically the performance of Visual Studio. We've got Phil Price, Senior Software Development Engineer and Test at Microsoft. How's it going, Phil?
I'm pretty good. How are you?
Not too bad. So I wanted to talk to you because I got in an argument recently with a guy who was telling me that his copy of Visual Studio, and this is his words, goes to Cleveland on a regular basis. And what he says when he says goes to Cleveland is it kind of goes gray. You get that kind of curtain of patience that happens, the smoky look. And the argument that we had was that I'm just not seeing that. And then I said, well, you should be running this thing called PerfWatson. So talk to me what PerfWatson is and why his machine goes to Cleveland and mine does not.
Okay, so PerfWatson is a telemetry system we built which detects when Visual Studio goes to Cleveland, as it were, and sends us reports on, what's happening at that point in time inside Visual Studio that, it became unresponsive. So it's a little extension installed inside Visual Studio, and what it does, it monitors the main message loop of the UI thread, and if it doesn't respond for more than 2 seconds, it then goes and captures the state and sends it up to us. And then those reports come via the internet, and then we aggregate all the data on the back end, and we look at why people are slow. Now, why he was slow, it can be any number of things, but with a report, we say, hey, it goes to Cleveland, hey, it's become unresponsive. We definitely know that the UI thread is busy. So often we're actually constrained on things like file I/O. We're doing large operations on the UI thread. Maybe we're reading through a bunch of files or doing some kind of scan of assemblies, and that, we're not necessarily doing that in the right place. We're doing that on the same place where you're rendering. So unfortunately, Visual Studio hangs. Okay,
so for context, for some of the engineers that maybe haven't done UI work in a while, maybe talk about the UI thread as it relates to the background thread and why would something like Visual Studio ever be doing anything on the UI thread? I thought everything was recommended to be, decoupled from the UI and the background thread.
Right. So, Visual Studio is, uses COM, right? So, in COM, there's two modes. There's STA and MTA, a multi-threaded department and a single-threaded department. Now, Visual Studio is a single-threaded department, which what that means is any COM services created, by default in Visual Studio as you initialize, unfortunately, are owned by the UI thread, and any call to them, regardless if you call them from a background thread, actually get marshaled directly to the UI thread. So, a little message goes in the message queue that says, hey, if you're running from if you're saying, hey, call this from a background thread, it goes in the message queue and then says, okay, I want you to run this piece of code, and it's going to happen synchronously, and it goes through the message queue onto the UI thread, calls the COM service, and bubbles back. So, unfortunately, it's not as easy as moving to a background thread, but now why Visual Studio is doing that, it's an old application, and really, it's about, scale. When we're using the same shell and technologies as we have been for, probably since, the first integrated version of Visual Studio, like .NET or 2003, can't quite remember. And rewriting these services to be free-threaded or, MTA has not, fortunately, been on our priority list. And we've kind of got away with that for a number of years. But then as Visual Studio's grown and got more and more and more stuff inside it, people are following the same patterns as they always have done. And, it's kind of like, we have this belt of the UI thread, and we're kind of putting on more and more weight, and this belt is constraining us, and now we're starting to, strain the belt, and we're not quite fitting in.
So are you saying that, is it that Visual Studio was written wrong before? And you said we got away with it? Or is it more that the techniques that that we learned about COM and threading didn't exist, 10 years ago? I'm trying to understand how much we got away with versus how much is just that newer techniques have come up.
Yeah, I would say that, I think that threads have existed as long as, Windows has existed, probably. And it was just really a case of getting away with it. We didn't really need to, right? We, if you look back to, say, the earlier versions of Visual Studio, we weren't doing quite so much. But, features come in that say, one that springs to mind is, hey, I've got a bunch of unit tests and I want them to automatically update as I add a new unit test, right? That work needs to happen somewhere, and that's happening on the UI thread.
I see. And is it also a matter of scale? Because even though computers have gotten faster, some people have said, well, parts of Visual Studio have gotten slower. Is that because, someone might have 50 solutions when 5 years ago they had 10?
Right. Yes, definitely. I think that, our applications are getting bigger. And also, I kind of lost my train of thought there.
That's okay. I realize that these are kind of challenging questions because I appreciated that you were going to come out and talk about this, that when someone comes up with a tool like PerfWatson, you're acknowledging that there are parts of the application that have issues with performance, and you don't want to say something sucks just because you fixed it. This is actually a funny thing we were talking about on Twitter a while back, that I think Microsoft sometimes can learn from Apple. Apple often comes out and says things, this is 500% faster. But they say it in such a way that doesn't make you feel like, wait a second, was it 500% slower a minute ago? So with Visual Studio, you want to accentuate the positive and realize that we're putting the effort in to figure out how these things can be made faster. So PerfWatson, you're running inside Visual Studio, but if Visual Studio is not responding, how do you know? How do you know you're not responding?
Right, because we are off the UI thread.
Okay, so you're running in process to devenv.exe.
That is correct, yeah.
Okay, and you can't be the bottleneck. You're well written, I guess. PerfWatson is not something that could be slow.
There is a certain cost to capturing the information as to why you were slow. I'm not going to deny that. We need to write. What we actually do is we capture a dump file at the point of a hang, right? But we've already delayed for 2 seconds. So we do increase the length of that delay ever so slightly, only if you're running PerfWatson. So, there is an overhead to that, but the actual part that monitors in process is extremely lightweight. It uses detours on the operating system calls that do the message loop, and then it's basically a tiny little canary thread, right? So we say, hey, we know we've processed the message, and we know we've entered the processing. We're going to process some input or an RPC call, and then we just sit down on the background thread, with what's it called, an event handle, and we're just saying, when you're done processing, you just set the event handle, and we're like, okay, we're good. We were under 2 seconds. Then if it goes above that range, then we call actually to an out-of-process component, which is a little PerfWatson service.exe, and we use a name pipe, and we say to that, hey, you need to go and capture a call stack for Visual Studio right now.
I see. So one of the terms that you used in there, we want to make sure to explain those to the listener. It sounded like you said canary thread?
Yes.
And is that a reference to a canary in a coal mine?
That is a reference to a canary in a coal mine, yes.
And for people who may not be familiar with that bit of English colloquialism, the idea is that people would carry canaries into the coal mine, and they would have these birds in cages, and if the bird died, that meant that there were gases in the air and that we should run. And a canary is kind of universally recognized now as something that's telling you that something bad is going to happen. So you're saying that you have a little thread that's running and watching for that little bit of gas that means we're all going to die, and then you capture that information. But it sounds like what you're doing inside of Visual Studio is extremely small, and anything that would be large, like you said, is out of process.
Yes, but you do have to remember that when PerfWatson Service exe, the out-of-process component does capture the dump file. It's a mini dump. It does have to pause all the threads and then, pull all the information out of memory to represent the call stacks on all of those threads. So there is a cost to that.
But of course, I'm already hung at this point, so it doesn't really matter.
Exactly. It doesn't really matter.
I see. Now, how did the number 2 seconds get picked? Like, if it's not responsive for 2 seconds, we jump in.
It was what we consider to be egregious, right? So the general guidance actually for responsiveness, things like input, it should be under 100 milliseconds, right? We want to shoot for stuff like 50 millisecond response time for things like input. And then, the guidance kind of gets, there's certain stages, like a busy cursor can be for, say, 1 to 2 seconds. And then if you got over 2 seconds, people are starting to get really annoyed, and you should really be putting up some kind of UI saying, hey, I'm doing a bunch of tasks, like a kind of progress bar saying I'm doing A, B, and C. So we kind of landed on 2 seconds there because we were well aware we weren't putting up responsive UI, and it's the point we felt that folks would get really annoyed. It's definitely on the high end. We definitely want to shoot for better than that. But we said, let's just go and get all the egregious cases and start there. Then moving forward, we'll probably move that limit down to maybe 1 second, then maybe even in future down to like half a second.
Wow. Okay. And does that value matter based on how fast their machine is? Like, I know that they want Visual Studio to run decently well on like Atom processors and small netbooks, but 2 seconds is 2 seconds no matter how many processors you've got.
Correct, yes. We consider anything above 2 seconds that hang in the UI thread egregious, and we want to fix it.
No matter, what's your low-end computer? Like, what's a reasonable computer? I get that question a lot. Someone's got like a dual-core Atom and maybe a gig of RAM or 2 gigs of RAM. What's a reasonable netbook to run Visual Studio on?
That actually sounds about right. About 2 gigs of RAM, dual core, should be reasonable. We should have a reasonable experience there. I'm not sure what the exact min specs are, but to me, that sounds about right. Okay. So then, does everyone have PerfWatson already? Do all Visual Studio 2010 people have that, or do I have to go and install it first? You have to go and install it. It's available on the Visual Studio Gallery. So inside Visual Studio, if you go to Tools, Extension Manager, and you can search for PerfWatson on the online portion of that, and there's a little extension there. You can hit install, and it goes and installs it onto your machine. And now for the developer preview release that we released at Build, all installs have it on by default. It was in the box for Build.
Do you think that'll be in the box like at the end? It seems like the kind of thing I would want in the box.
I don't think we'd have it at the end because, as I talked about, there is a certain cost to capturing that information in the outer process part.
Right.
I think, for a developer preview or maybe a beta, that's okay because we want to get that information. But for a full release, we don't want to induce that cost onto everybody if they don't want to pay it.
Now, we want everyone to install PerfWatson, but like you just said, there's a cost. Without freaking people out, are we looking at like small single-digit percentages? I mean, can you guarantee that in the course of events, just like regularly doing my job, it's not going to slow me down? It's really only when the dump happens?
It's definitely 100%. It's only when you're hung, then we'll go and capture that information. That's how it works. The cost of collecting that dump file is, anywhere between, I would say, best case, 250 milliseconds. So it's a very small percent. It's not a large percentage of 2 seconds, but it can, if there's a lot going on in the process, it can go up into like the 1.5 second range.
Okay. So we definitely don't think that it's a problem to install this on your regular machine and keep it running and forget about it. I know that I installed it a while back, and I honestly haven't thought about it since. I assume it's doing its job.
Yes. And I do have to say that all our internal builds, as we're developing Visual Studio, have it on by default as well.
Okay, cool.
And, we've been running that for like a year plus, and, at first we got a little bit of noise because we used to show a toast that said, Visual Studio is coming unresponsive, we're collecting information. And people were blaming the delay, the actual whole delay, the 2 second part, which we weren't part of, on the toast. They're kind of like, it's kind of like, you ask a child, what makes wind? It's like, hey, it's really windy, and people are like, the kids are like, it's because the trees are moving, they make the wind. It's kind of that effect, right? Mm-hmm. But it's not actually. We were just showing a real quick toast out of processing. We're collecting this information. So as soon as we took away that toast and people didn't associate the toast with the delay, we haven't received any feedback.
Okay, that's cool. So I've got this installed. You said all internal builds. There's a whole lot of these out in the world now. I guess we can go up and look at the downloads on Gallery to get an idea of how many of these are. They're all talking back to you. I assume if this happens on an airplane, you'll queue it up and send it to me later? Or send it to yourself later?
Yes, with the external version, what we do is we queue them all up from a particular session. Then the next time you start Visual Studio, we're going to show a prompt saying, hey, do you want to go and upload this information?
Okay. Is this a lot of data?
It depends on the length of your session, right? So each dump file usually weighs in between, I'd say 500K to 2 meg. It depends, how many threads are running and what they're doing.
Okay.
And, a course of a session, I probably think about you get 10 to 20 delays. And then, quick maths there, probably couple, 10 megabytes of data. And then you hit OK, then we'll just go and upload that on the background. I think we use Windows error reporting, which uses like background transfer, like bits and stuff. So, the bit service, so it doesn't interfere with your regular browsing. So it kind of uploads on a very low priority in the background.
This episode of Hansel Minutes is brought to you by Careers 2.0. Careers 2.0 is a new service by our friends at Stack Overflow. You're probably all familiar with Stack Overflow, the online Q&A resource dedicated specifically to programmers and programming-related topics. Well, the team at Stack Overflow created Careers 2.0 to provide you with access to great jobs and introduce you to a bunch of great companies that you might consider working for, even if you're not currently looking for a job. Think of Careers 2.0 as a programmer profile. It gives you a platform to show that you're awesome by featuring your proudest contributions to Stack Overflow, GitHub, SourceForge, Bitbucket, anything programming related. You can even add your favorite programming books from Amazon.com. Profiles on Careers 2.0 are free. They're easy to get started, especially by importing your LinkedIn profile. However, there's one catch. Profiles on Career 2.0 are invite only. They did this to keep out the spam and have a high-quality environment. Fortunately for you, as a Hansel Minutes listener, I've got your back. Head on over to careers.stackoverflow.com/HM to accept your invitation today. Once again, that's careers.stackoverflow.com/HM. I hope you like it. So definitely if you're in Uganda and on a 3G modem, be aware that PerfWatson might not be for you, or you might want to turn it off. But, 10 megabytes here and there, if you have the bandwidth, it sounds like it's valuable. Yeah. Now, sometimes people, when you install a Microsoft product, they pop up a dialog box that says, do you want to participate in, sending us all this information? Do you want to be a member of our, advisory council or whatever crazy language they put in there to say, I want to send info. And we always wonder, where is this going? And what are you doing with that? And why do I want to help you? Because you're the one that's making me slow. So I've seen people say no just to be vindictive.
Right.
And I think we just assume that the data just goes nowhere and it's just sitting in a giant database somewhere. What does it look like? Is this in Azure or is this a giant farm somewhere? And what are you doing with all this?
Right. So in the case of PerfWatson, we have this big old SQL server. It's 64 cores, 128 gig of RAM, kind of crazy machine. And what we do with those dump files, we locate the UI thread within the dump file, then we resolve the symbols, which allow us to get, the full method name and module, and maybe even the line number, which is being called. So we extract all that information out 24/7. It's just any dump file that comes in, we extract it out, and then we go and take that call stack and insert it into a database. So we've got tons and tons of call stacks all in this big database. We do some smart things like we hash call stacks so we don't insert duplicates and associate a certain hit. We call it a hit is our internal nomenclature for it. So a hit is associated with a call stack. And then once we have this big database of hits and call stacks, we then we do aggregations and we create a call tree of all call stacks, maybe within all data or within a particular build. So in the case of the developer preview release, we're looking at that right now. And what we'll do is we'll say take all this data and put it into a call tree. Now, how that works is each call stack is slightly different, but a lot of them are the same. Imagine at the beginning you get thread start and then VS main and then, I'm in the message loop. And then it goes off and does different things. So this kind of aggregation or call tree, we also call it a roll-up, basically shows you the splits in execution and how many people experience a delay down that certain path. So we kind of get this overall big feeling about, oh, here's the heavy pass. We saw 2,000 people have a delay down this path. Then what we can do we have this website we use internally, which is a Silverlight web app, and it allows you to query into this data. So imagine you've got this roll-up and you're like, oh, I see an interesting frame. Maybe it's something like solution open. You can say, show me just the data where people are, all the call stacks that have solution open in them, and then we'll get a roll-up of, just that portion. But why we do that is because we can get more depth, because we cut off at, I think it's 0.05% inclusive, so which is basically like if less than 0.05% of users experience that delay, we don't show it in the tree.
So not 0.05 is 0.05%, is that correct?
That's right.
Okay. So you're saying a very, very small amount.
Yes. Well, it depends on the size of the data set as well, right? It's kind of, and it doesn't mean that they're not going to be ignored. It just means that, hey, we've got so much data, we really just don't want to pay the cost of calculating that entire tree and storing it. Mm-hmm. So you split it off, say for solution open, and then what you do is you go through that, and we have like a hot pass feature which shows you where the majority of the cost is. And then you may go and associate that with a bug in our bug tracking system, and then we track that delay to that bug, and then we push that to be fixed.
Interesting. Okay, so this is complicated. It seems like Microsoft has moved towards this telemetry thing, and maybe it's always been a Microsoft thing, or maybe to me it feels like somewhere around Windows 7, this culture of intense analysis. Like if you look at the Building Windows 8 blog, they'll throw these numbers out very casually, and they'll say something like, and I'm making this up, they'll say like, only 13% of people click on the start menu on a Tuesday, and that made us design the system in this way. Da, 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 da. And I'm thinking to myself, wow, is that all the data that's what they got from my anonymous data? And now you've got this giant SQL server that's showing like how I'm moving around in Visual Studio and telling me stuff like, I assume that you also know whether I use a hotkey or not, and maybe the hotkey was the slow path versus using the UI right-click menus and stuff like that.
Yes.
Is this just something you wander around in, or is there an automated like email that goes out that says, here's the 10 hot things that happened this week? 5,000 people hit this week.
It's not fully automated. We definitely like to get there. But I'm personally a big believer in like human analysis. We had a choice when we were developing this, like, could we go and make something that's fully automated and going to tell us automatically what's wrong? But it turned out it was pretty hard to do, and a human could usually do it in the space of an hour. So once we split off the issues into, we call them queries within our system. So when I talked about splitting solution open, that kind of thing, when we split these off into separate queries, then at that point we associate a bug with them, then we track them. So we can say, we started off with 1,000 people hitting this, and now we can see that this is growing over time, or this is a persistent issue, and things like that. But it's definitely not automated. We do have reporting that goes out that says, "Hey, these are the top 20 issues in a release," but that starts with human analysis at the beginning.
And do those top issues, like they get like visibility, like bosses are like looking at that and they're like, come on, Phil, what the hell's going on with?
Yep, definitely. I've got definitely lots of emails saying, what's going on with this? How come there's not a bug associated with this new trend and things like that? It goes out. We have internally a performance champs alias, which is top people working on performance for each of the teams within Visual Studio, and the report goes to there, and then it also goes up to leadership as well.
Wow,
so it definitely has great visibility.
So I don't know if it's cool that you've snuck on my show, and I appreciate that I'm being able to ask you all sorts of questions. I think it's cool that teams that I know that my team is cool with telling stuff out, very transparently, and I think it's really cool that you are doing that as well. So let me push your good nature a little farther and say, tell me some really good bug. Give me an example where you put PerfWatson on and within the first couple of months you discovered something and no one thought it would have been slow, and turns out that, everyone was catching this issue and it was sending us to Cleveland.
Oh, yeah, no problem. This is actually a very strange one. It turned out to be something from Windows. So when we process messages, when there's no messages to be processed or input, we enter a thing called idle, which is basically the UI thread is doing nothing. And you can schedule work here, right? So you can say, when you've reached idle, this is kind of like if you're using DoPF and you say, dispatcher begin invoke, and you say, priority application idle. That means, hey, there's no input, go and do something on the UI thread. We go off and do idle tasks. And one of these was a really innocuous, super innocuous, sleep EX call to the operating system with a time of 0. And you'd be like, why would we do that?
What does that mean? Slow down a little bit and give me a little more detail.
Okay.
So the system is, no one's doing anything. I haven't moved my mouse in a while. And this is a good time for Visual Studio to catch up on some little things it needs to be doing. Yes,
exactly. And one of those little things was sleep with a 0 timeout, and you're like, well, why would you want to sleep with a 0 timeout? Mm-hmm. Well, this is for processing APC messages, which are like another kind of RPC, another kind of scheduled message. And more often than not, actually, there was only one feature using this, and we took it out. But we still see delays in this sleep call. And we're like, well, it's sleeping for 0. Why on earth are we delaying for 2 seconds here? And it turned out that the Windows Window Manager can actually take a global lock on sleep timers, and it may be, hey, Windows is going off and doing something, and our application would hang because of that. And it was totally safe to remove the code. So it was totally innocuous, totally unneeded code was causing us to delay on quite a regular cadence.
So let me see if I understand this, because paraphrasing helps me learn.
Mm-hmm.
There was a way that a component in Visual Studio was using to communicate with parts of Visual Studio, and that component had been long removed. But the part in the message loop that said check to see if that component has anything to say was still there. And it happened to use a communication technique that Windows itself used, some historical Win32 thing. So, you might have some bizarre side effect like Windows is looking at your SD card for pictures and using this communication technique, and Visual Studio is in the middle of an idle loop. So, a bird flaps its wings in Brazil and a hurricane happens in New Orleans.
Exactly. And it was, we'd never expect that. Another one, which was, when we have the wait cursor that comes up in Visual Studio, obviously, right? Something's busy. And the way we do that, actually, we never actually say start and end cursor. What we do is we say start cursor, and the next time we've processed all the input, that we automatically reset it. And we'd use a timer for that. Now, it turns out that another thing which we never thought would harm us is that, for much the same reason as the sleep example, would be killing that timer, even if that timer doesn't exist, which is totally valid according to the documentation, could also cause a hang. And we are doing this again in the idle loop in Visual Studio.
Oh, so that's actually a matter of the documentation indicates the API would behave this way, but reality indicates it does not.
Yeah, sometimes it may. And we talked to actually Raymond Chen, and we're like, hey, what's going on with this? He's like, well, looking at the code, there is a possibility that someone may have a lock on one of these things. So you shouldn't kill. So, the thing was, if the timer's null, don't try and kill it. Just don't do it. And that fixed the issue.
So these issues are things inside the idle loop. How often does it come up where some component or some, I wouldn't say third party, but internal third party component in Visual Studio has a problem? Like I had a couple of conversations, and this guy I was talking about who came up with the term going to Cleveland, and I was saying, well, my machine's just not locking. I don't see these delays. And he says, well, I'm doing XAML work and I'm using the XAML editor. And I realized that designer, that visual designer, isn't loaded on my machine until I actually open a file like that. And that's a very common thing in Visual Studio, that, DLLs and componentry won't be opened until I decide to do that, like the Solution Explorer or the data, the data connections area or the XAML Explorer. How do you find those? And do you have to call that group and say, hey, other guy at Microsoft, you don't know me, I'm Phil, and turns out you're really slow.
Yes. No, I do that all the time, We do have a template for our bugs that has guidance and stuff like that. But yes, definitely. We can see stuff like, hey, you pressed a key and then it went through into the editor, and we can see what kind of editor or design surface that was. And then that design surface may go off, and do some expensive operation. And one that I can talk to maybe is loading, the parameter info and the dot comments for like quick info when you hover over something.
Okay, so when you move your mouse over a method and then the little tooltip pops up.
Exactly. And that comes from XML documentation. So if that wasn't ready quite yet, it's like, well, I better finish reading this file, and we would just wait on file I/O. And a lot of the delays in Visual Studio that we've seen, I'd say a good 50, 60% are not necessarily poorly written code like, hey, I'm doing a for loop for ages. It's blocked on file I/O, and we do a lot of file I/O on the UI thread. And a lot of the fixes for that are making that file I/O lazy, doing it on a background thread, and then letting the UI thread know when it's ready.
So it sounds like a lot of this is really being, this has support. Like, this is being driven into the product, because a number of people have said that the developer preview of Visual Studio is a lot faster. Are you going through and you're fixing all these? Like the chart of obvious performance mistakes, I assume that it's the bar chart is going lower, right?
Yes. Now, some of them are easy fixes. The easiest fixes don't do it, right? Do you even need to do that? There was one case I can speak to with that. We have disaster recovery management, like auto recover is the name of the feature, and every 5 minutes it's going to go and save off all your documents. So we can have a backup in case we crash. Now, that's all goodness. But in Visual Studio 2010 beta, we had, some stability problems. So we also put a thing in there for saving the active window profile in case you crash. And that's like where the positions of your tool windows are and stuff. And so every 5 minutes, we'd be saving the window profile. And the fix for that was just don't do it. We don't need to. We fix the stability problems with the window manager and the shell, and we save when we switch from design to debug anyway. So, that's a case where we identified that and pushed that down. And yeah, we definitely do have support. Now, that was an easy fix, but there are some fixes that do require re-architecture, especially with some of these STA threaded things that I talk about. These services are 8 years old plus. And they're all set up to, have not really any concept of locking, because that STA call is essentially a big global lock. And that will take probably investment over multiple releases to get it to where it needs to be. We kind of pick off we pick the top ones and go after them and see what we can do. But we've also got to remember that this responsiveness is kind of like a death from 1,000 paper cuts. There's lots of little ones, which are lots of little easy fixes. And it may not be a huge win on the graph, but all of them in combination would be a good win for our customers.
That's a really good point. Do you have like a final story of the worst one that you found that required a re-architecture and made people really make a hard decision and go, oh man, that's going to suck. But if we do it, lots and lots of people are going to notice it.
Yep. Yeah, no, definitely. There's one in the developer preview actually, is we moved C# build out of process. So you think, hey, C# build out of process, right? It invokes the C# compiler. But that's all orchestrated via MS Build. And MS Build itself is the backing store to your project system. And we were actually evaluating that in process. So we had to spin off a team of about 6 people for probably about 2 months to go off and do this work and move this out of process and use .NET remoting to kind of call to the after process component part and get all the bits of information we need back in process and look through any performance issues that made itself, because we think, hey, we move it out of process, it's going to be better, right? But we have to verify that. We have to run it through regression systems and make sure it's where it needs to be. And so we had to spit off this team and change the way that was working. But it's worth it in the end, because now when you were building previously, if you're doing a big build, you try and maybe click around the IDE and it would just kind of half respond to you because we are faking responsiveness. Kind of like if in VB you do events and we kind of just push the message pump a little bit further forward, but kind of just doing that at random points during the build. We just moved it fully out of process. And it was a big investment, but it pays off, because now when it's building, you can click and open menus and use the object browser. You can even edit code if you wanted to.
Wow. Okay. So really? I can amazing. I can edit code now while I'm building. And I think with machines.
You may get a warning. If it's already built, then you're good, right?
Course,
if not, it's going to give you a warning. Now in VB build works a little bit differently. We moved that onto a background thread, and you can't edit code for VB. Because the way the VB build works is it's actually building all the time as you're typing. And then the build process is essentially a serialization of that pre-built stuff in memory to disk.
Right,
so we just
right. And that's something that VB's known for.
Yeah.
So this means that on a machine with a lot of processors, like my own personal machine, I've got one of the hexacore machines, moving things out of process like that just makes everything more efficient. I've got the extra processors to do that work.
Yep.
So this is a big win, not just because it made it more responsive, but it's also kind of more future-proofed. It makes Visual Studio less a big monolithic EXE with a bunch of in-process stuff and more a number of smaller EXEs that all work together.
Yes. And I think that will be a trend for Visual Studio moving forward, or at least I would hope so, right? The XAML designer in the developer preview release also runs out of process as well, because that needs to load a bunch of assemblies to do essentially figure out, reflection and figure out what kind of user controls and things like that you've got to give you the IntelliSense support. And so those assemblies need to be loaded and reflected over. And we were previously doing that in Visual Studio's process. We were doing it in a separate app domain, but it was still the same process. It was still the same memory. So moving things out of process also has a great memory benefit, and we've seen that with moving the XAML designer out of process.
Very cool. Well, thanks a lot, Phil. I really appreciate you coming on and giving me the straight story about what's going on in the next version of Visual Studio. It's cool because sometimes you don't see all these changes. Well, actually, you never see them all, right? Unless you're poking around in Process Explorer, no one's going to know a lot of this stuff is happening. But that makes me want to spend a little bit more time with the developer preview and I don't know, really test them side by side and see if I'm going to see these performance improvements as well. And of course, everyone should install PerfWatson.
Everyone should install PerfWatson, definitely.
Because Phil is going to be looking at that data for us.
Yes. I have a little team of people, and we look at that data all the time.
Awesome. Well, thanks so much.
Okay, no problem.
This has been another episode of Hansel Minutes, and we'll see you again next week.